Hi there, this is Mr. Ford, and what we're going to be doing is we're going to be going through arithmetic sequences, specifically the summation formula. Now this is a fairly simple formula. You're just going to be using some of the stuff you've learnt already, such as dealing with just arithmetic series, but then also how you'd find the sum of those to a specified number, whether it's a fixed number of terms or it's an ongoing series and you just want to find the first, say, 15 of them. So what you can see here is two main formulas. They're the ones that we're going to be operating with today. So the one on the left is a more general formula, okay, whereas the one on the right is a simplified formula. Now the one on the right is very useful because what it actually tells you is, so let's read these out. So first, the one on the right here, this one here, we have the sum, that's why we got this capital S, of the n number of terms. Okay, so this just means sum of the series. This is the specified number of terms. Okay, well that's equal to how many terms that is, the same n, over 2. And then we've got this little expression here. Okay, you might sometimes see this as this, specifically those overseas. Okay, or you might see this T1 replaced with an A, especially if you're doing GCE or an international school. Alright, but all it means, so this T1, as you should already know already, T1 just represents the first term in a series. Okay, the same as A. Tn, well, if n is the number of terms, let's say that I want to find the sum of 30 terms. In the same case, T30, well that's the 30th term. So actually this, or this, represents the last term in the series. Okay? So to break it down, the sum of a series, so of the n number of terms, is equal to the number of that series over 2 times, this is the last term, plus the first term. And that's it. Very, very simple. Now, I'll show you a question in a moment, but if you don't have the last term, you can use this formula on the left, and I'll show you how that's done. So what you should know by now is this series down the bottom. This one here represents the term in an arithmetic series. It's your general arithmetic formula. So for the nth term, so let's say if I want to find if the first term, you would do t of 1, which is our first term, plus, well, since we're finding the first term, we're doing 1 minus 1, because we're putting n is equal to 1 in both of these positions, times by the d, which is the difference between the terms. Okay? Which then these cancel to 0, which means you get your first number there. But you should know this already. It was just a quick little recap. So what you can do, since we know t of n, you could sit there and you could pop this in like this. So you get n over 2. Now in place of t of n, I'm going to substitute this expression here. So that there is t of n. And don't forget, we also need to add the first term there. And you'll notice inside this bracket here, you'll be able to collect the two first terms, t1 and t1, which gives you 2 times t1 plus n minus 1 d. So it's just another formula. This is quite useful if you have the first term, the difference, and the number of terms, but this one on the right is very useful if you've got the first and the last term. So let's look at some questions. Okay. So your first question here is find the sum of this series. So first off, this is our start sequence, so we can already tell that the first term is 3. So the first thing I write down. The second thing you notice is every time it's going up by 4. So it is an arithmetic series, So that means that our difference is going to be 4. Now, this one asks us to do 20 terms. So because of this situation, it's nicer to use this formula. And all we do is we substitute things in. So in this case, we want our n to be 20. So we're finding the sum to 20 terms. Okay, well that's going to be 20 on 2. Then we're going to do 2 times t1, which is 3, plus n is 20 still, times d, which is 3. Alright, and then we pop this in here. Alright, so we get 10, and that's going to be 6, plus we have 19 times 3. I've made an error here. So that would be 4. So it would be 19 times 4. And that would become 82. So your answer is 820. Now, just for example's sake, I'm going to show you the other formula. Okay, so to be able to use the other formula, we need the last term. We need t of 20. So this is where we use our general formula. So that's going to be, remember, it's the one up in the corner here. So we're going to use 3 plus, it's going to be 20 minus 1 times 4, which is going to be 3 plus, and you can already see on the left hand side how similar it is, 19 times 4, which is going to be 79. Alright, so now we have our first term is 3, our last term is 20, so if we want to find the sum to 20, we could just use the formula for the first and last term. I'll write it here just so we remember. Where this is the last term and this one is the first term. So all we do is we put 20 over 2. Obviously you could just write 10, but I'm just going to do the full working for you. Our last term, our first term, and you'd already see this is 10 times 82, which is 820. Okay, now let's try 2 more questions which are slightly different but require us just to use our formulas in different ways. So in this question, what we've been given is we've been given the first number, but we've also been given the last number, and you can determine the difference. So let's quickly just do that. So our first number, our last number. But this is the problem. We don't know how many numbers are in the sequence. We also know our difference. Is plus 11, and it also tells us the arithmetic series, so that means our difference is positive 11. Don't need to write positive. Now let's go back to our formula. If you have a look at our formula, we have a t of n, we have a t of 1, and we have a d. We have our difference, so we can actually substitute this in to find the missing n. So that's exactly what we're going to do. I'm going to do it underneath this so you can see on the right hand side. You've got 292 equals the first term, which is 17, plus n minus 1 times the difference, which is 11. Now I'm just going to do some rearranging here. And we can divide by 11 on both sides. Which means add 1 on both sides. Now n equals 26. Now we have a choice with our formulas. Our formula, which is easy to use, is the first and last one. Sum of n equals n over 2. And then we've got the last plus the first term. Nice and simple. So we know there's 26 terms to this series. So the sum of... I'm sorry, I'm jumping ahead. So the next question, actually on the next slide. Okay, so if we go to this one here, find the sum of these n terms. Well, we still have our first term equals 17. We have our last term, which is 292. But we now know our n from our previous one is actually 26. So now we can use our formula. Okay, so our sum of the first 26 terms, which is these ones here, is going to be 26 on 2. And then in here we'll have 292 plus 17. Type that into a calculator and we will get 4017. Okay, I have one more question for you and then 3 questions for you to try. So this one here is exactly the same. We just need to find the sum of this series. First off, let's first find out our difference and our first term. So we have our first term being 4. Our difference here is 3 because it's adding 3 every time. And our last term is 91. Okay, first off we need to find out how many terms are in the sequence. Okay, so we know that's 91. Our first term is 4. And our difference is 3. Subtract 4 from both sides gives us 87 equals n minus 1 times 3. Divide by 3 on both sides. So we have 29 equals n minus 1, which means when you add 1 to both sides, you get n equals 30. Alright, we now have all the information we need to use any of those formulas, but let's do the nice simple one. So let's do first and last. So it's s of n equals n over 2, and it's the last plus the first number. And that means the sum of the first 30 numbers, which is these ones here, is 30 on 2 times the first and the last number added together. 1425. Okay. So what I want you to do is make sure you've understood the process I've explained to you now, and then I want you to go on to this next. I'm going to pull over to this slide here. There's 3 questions that I want you to work through. Okay. After this, there is going to be a short delay, and then there's going to be some work solutions for the rest of this here. Okay, so this is just going to be a continuation of this. So what I'm going to do here is I'm just going to go through the work solutions for these. Make sure you've given each one a go. If you want to do one and then wait to check it, you can. I'll be breaking it up in the video so you can do that. Okay, so on these ones I haven't actually done them, so I'm just going to go through them with you. So the first one, we have 14 terms, so that means n is 14. The first 14 terms. It tells us our first number is 5, so this is our T1 equals 5, and you can see in this case it's going down. All that means is our difference is negative. So our difference is negative 4. Alright, to start us off, let's find the last term, so that's going to be T14. Which is going to be the first term, so T1, plus n minus 1, which is 14 minus 1, times the difference, which is negative 4. So we get 5. Then we have, so this is going to become 13 times 4 times minus 4, which is going to be, so we got 26 minus 52. which is going to be minus 47. So we now have our last term, our first term, and the number of the sequence, of how many in the sequence, and all we need to do is apply our formula. Okay, so then you'll end up with 14 over 2 times by our first number and our last number added together. So 7 times negative 42, and I just need to very quickly do this to check. So we have 14 carry the 1, 8, so that's going to be 294. So we get a negative 294. Alright, let's have a look at our next one. So make sure if you haven't done it, go and do it now. Right, oh, this one goes down as well. So first off, let's pull out our information. We have our last number, we have our first number, we have our difference. We don't have the number of the series, so we've got to find that out. So we have T1 is going to be 34. Our last number, Tn, is minus 111. And our difference, alright, minus 5. Our difference is minus 5. So first off, we know what our last number is. We just need to find out how many numbers in this series. So using this formula, we need to substitute our known values in to find the missing n. So we know that when t of n is minus 111, okay, this is the last one, we just want to find the n. We've got the first number is 34 plus n minus 1 times by negative 5. Okay, so I'm going to take 34 from both sides, just nice and balancing. So it's going to be 5, we've got minus 145 equals n minus 1 times by negative 5. Divide by negative 5 on both sides to get rid of that. Okay, so they cancel. Alright, so you have 29 equals n minus 1, so n equals 30. And the rest of this is pretty simple. I have all my information. So my sum of the first, this is going to be the 30 sequences because this is the 30th number. It's our last number in this series. Okay, sum of 30 is n over 2, so 30 over 2, times our first and last numbers added together. So we have minus 111 plus 34. Alright, and all we need to do is just type that out. So we have minus 7, we have 15 times minus 77, which is going to be minus 1155. If you got that correct, give yourself a big tick. You're doing well. Last question, just a worked example. Here we've got an algebraic term. So same thing. We have, alright, so we have our first term. We have our last term here. And if we have a look at our difference, now this might not be clearly apparent, so let's have a look. There's two ways we can do it. The common difference should be this minus this. So if we do 2x plus 1 minus x plus 1, okay, that should give us a difference. If you have a look, that's going to very simply just turn into x. So, and you'll notice the next is the same. If I add x, I go from 2x plus 1 to 3x plus 1. So our constant difference is x here. Some of you will figure out what this is straight away, but that's okay. We're going to use our process. Okay, so this is our difference. Now, we know our t of n, which is 21x plus 1. We know our first term, which is x plus 1. Plus, now we don't know our n yet, which we need to figure out, and our difference. Now our difference is just x, nice and simple. So the first thing we need to do is we need to take x and take 1 from both sides, so we can get rid of that, which gives us 20x, and you'll notice this cancels out, equals n minus 1 times x. If we divide by x on both sides, you can see where we're going here, and that means our n is 20. Alright, so we have our n, we have our first and we have our last. We can do our sum of these series. So the sum of the first 20 series is, so we have 20 over 2, just like before, times our last number plus our first number. So it's going to be 10. And in the inside, all we have to do is collect our terms. So we've got 22x plus 2. Now, because we're good mathematicians, you can either expand, but you'll notice that there's a common denominator in here, so we're going to factorize those out. So it's going to be 10 times 2, and we've got 11x plus 1, which means we'll get 20 and times 11x plus 1. That would be our sum of our 20 terms. It is the same as if you expanded it and you would have turned around and got 220x plus 20, but this is just nicer and neater. Okay, thank you so much.